Here we have a concentration problem. When I do these, I always start with the buckets. We're mixing two things together to get a third. So the total chocolate fountain has 500 liter capacity. It already has 25 liters of 40% milk chocolate. And he's going to add X liters of 90% milk chocolate. To get a certain amount. He does not have to fill it up all the way. So that doesn't mean that he's going to fill it up to 500. He's not going to have 500 at the end. He's going to have however much he adds plus 25. It does not need to be full at the end. And then depending on how much he adds, that's going to tell us what the concentration will be. So I'll put a C there. So this is inside each bucket, you multiply these things. You multiply the percent times how much, percent times how much, percent times how much. So that's 0.4 times 25 plus 0.9 times X equals C times X plus 25. So we got to get C by itself. It says write the concentration as a function. So C equals, we got to divide by X plus 25. So this is our equation. I don't want to rewrite the entire thing. So I'm just going to say C of X equals this equation. So we can type that into our calculator here in a little bit. First, we're going to sketch the graph. First thing we got to remember is that it already has 40% milk chocolate in there. It's not going to go lower than the 40% because that's what's in there already. And we're adding a stronger, more concentrated chocolate solution. Now, what we're adding is 90%, so 0.9. That creates a horizontal asymptote. It's never going to pass that. It'll get closer and closer, but it's never going to pass the 0.9. And that's really all you got to know. Is it starts here and goes with an asymptote. The other key to this that is important is that it has a 500 liter capacity with 25 liters already in it. 500 minus 25 means we can only add X. We can only add up to 475 more. Then it's full. Anything past that, it's going to overflow. So there's the graph. Explain what concentration appears to approach as the tank is filled to its max. It's getting closer and closer to 0.9. We can get that actual value by plugging in 475. So our numerator with big parentheses around it is going to be 0.4 times 25 plus 0.9x. That's our numerator, divided by our denominator with parentheses is x plus 25. And we got to fit our window to this. Our y values go from 0 to 1, essentially. And our x values have to go from 0 up to at least 475. So our x values first, 0 up to at least 475. I'll go in even 500. And our y values go from 0. They only need to go up to 1 because they're percentages. So there we go. Starts at 0.4, flattens out towards 0.9. So when it's filled up, we check x equals 475. So that's a G solved y calc. X equals 475. That's when it's filled up. So when it's full, it hits 87.5. We said it's getting closer to 0.9, but it's never going to reach it. When it's full, it hits 87.5%. Now, changing that wording a little bit, if it had an infinite volume that it could hold, then it would keep getting closer and closer and closer to this 0.9. So if it went forever, it would be 90%. If we want the concentration level to be 60, how much should we add? So now that's going to be an X calc when Y equals 0.6. X calc Y is 0.6, so we get 60%. We only add 16.66 repeating. That's how much we added, which is measured in liters. So 16 2/3.